Hello guys, welcome back to VC Tech. What happens if your network path suddenly fails? Does your network stop working or does it automatically recover? Today I'm going to show you how floating static routes act as a backup route that only activates when the primary route goes down. If you want better redundancy, smarter routing, and more control over your network traffic, this video is for you. Before we get into the configuration phase, let's have a bit of a knowledge about what floating static route is. A floating static route is used as a backup route with a higher administrative distance number that only becomes active when the primary route fails. Floating static route remains inactive during normal operation. As long as the primary route is active, floating just stays in the background and watch for its time to come. So why floating static routes are important is it provides redundancy and fault tolerance in the network. It also prevents downtime, and it is a simple alternative to dynamic routing, as well as it is ideal for backup ISPs or WAN links. How floating static route works is there is a primary route with a lower administrative distance number, and we also have a floating static route with a higher administrative distance number. The router always prefers the lower administrative distance number or administrative distance route. If the primary route fails, the backup route activates automatically. That is what we are going to be configuring on the lab. So for this tutorial, we are going to be using 4 routers, 2 switches, and 4 host PCs. On these routers over here, we are going to configure the primary route. We are going to be using OSPF as our primary route and a floating static route on this interface to carry out the backup route. So whenever the primary route is down, the backup route kicks in. I've already assigned IP address to all the interfaces that we are going to be using for this tutorial. Now let's configure a routing protocol that will serve as the primary route. So whenever this host devices right here want to communicate with this host devices over here, let's just label this. So this will be site A, and this would be site B. So whenever site A wants to go to site B, they're going to be using the primary routing protocol, which is going to be OSPF. Now let's configure that on this router before we get into configuration of float static routing. So we say router OSPF with a process ID of 10, and we want to specify the router ID, which is 1.1.1. We'll be given 1.1.1. And we also want to specify the networks that are directly connected, which is 192.168.10.0 network with a wildcard bit of 0.0.0.255 area 0. We are also going to do the same for the other networks, which is 128.64.10.0 with a wildcard bit of 0.0.0.255 area 0. And for the last network, which is 128.64.20.0. So 128.64.20.0 network with a wildcard with a wildcard bit of 0.0.0.255 area 0. Now we've configured OSPF on this router, and we'll also configure OSPF on this router and also on this router. I'm going to do that real quick and get back to you. Alright guys, so I've configured OSPF on this router this router and also this router to serve as the primary route. So whenever this device is over here wants to get to this device over here, they will be taking the primary route. Now let's get into the main topic for today, configuring floating static route on the router. So we are going to configure float static route on this router. Remember, a floating static route is a static route with a higher administrative distance number. We are going to configure floating static route on this router. So let's do that. As you can also see, our OSPF configuration has form neighbor with the router of 1.1.1.2, as well as the third router has also form neighbor with 1.2 router ID. Now let's configure floating static route with a higher administrative distance number. So we say IP route with the destination network that we are trying to go to, which is 192.168.20.0 network, which is the site B network, with a subnet mask of 255.255.255.0, and we want to be getting to this local area network through the next hub IP. Now the next hub IP from this router is this interface over here, which is interface gig 0/1 on this router. It has the IP address of 128.64.20.2. So we do that here, 128.64.20.2. So this is the route that we'll be taking to get to site B. Now we are going to add a higher administrative distance number, letting the router know that whenever the primary route is down, this floating static route should kick off, and we'll be using a higher AD number of 130. Remember guys, on this router is where you configure the floating static route, while on this router you configure a normal static route to carry out the traffic. So let's do that real quick. So we say IP route with a destination of 192.168.20.0 network with a subnet mask of 255.255.255.0, and it should be using the next hub IP address of this interface over here, which will be taking 10.10.20.1. So let's specify that here, 10.10.20.1. Remember, on this router we configure a normal static route. Then our traffic is able to go to this local area network if ever our primary route fails. Let's also configure a floating static route for this local area network, so whenever their primary route fails, they will be able to take the backup route. So we do the same. We say IP route with the destination of 192.168.10.0, which is site A network, and it should be using the next hub IP from this router. The next hub IP is this interface over here, interface gig 0/0, which will be taking 10.10.20.2 with a subnet mask of 255.255.255.0, and the next hub IP is 10.10.20.2 with an administrative distance number of 130. Remember, this is the backup route whenever the primary route fails. Then we are also going to do the same configuration here. This time around, it's just going to be a normal static route. So we want to get to the destination of 192.168.10.0 network with a subnet mask of 255.255.0, and we want you to take the next hub IP. The next hub IP from this router is this interface over here, interface gig 0/2, that will be taking the IP address of 128.64.20.1. So 128.64.20.1. By doing this, guys, we've configured floating static routes on both local area network from site A to site B. So whenever the primary route fails, the secondary route kicks off. So let's check the IP address. Yes, we have an IP address for this device. Now let's ping from this site A network to site B. We do that by saying ping 192.168.20.1. Let's ping 20.1, and yes, we are able to gain connectivity to 20.1. Now let's trace route and see what route that the traffic is taking to get to that destination. So we say 192.168.20.1. And as you can see, guys, it left our default gateway of 192.168.10.1 and it went to the next hop IP of 128.10.2. And if we check, 10.2 is on this router over here, 128.64.10.2. It means our traffic is taking the primary route to get to its destination before it got to 192.168.20.0, which is the default gateway for this local area network over here. Now let's also ping a local area device. So we'll be pinging .7. So let's ping .7. We are able to ping .7. Let's also trace route and see what path it's taking to get to that destination. It is also taking the same path, which is 128.64.10.2, and it also went through the next hub IP of 10.10.1 before it got to our device that we are trying to connect to. As if we try to do the same from this local area network, let's see the IP address. There's an IP address. So let's ping from this local area network to the other local area network, then we trace route and see what route it's taking to get to that destination. So let's ping .5. We are also able to ping the local area network of site A. Let's also trace route and see what route it's taking or what path it's taking to get to that destination. So let's go to .5. So as you can see, it's taking 10.10.10.2 next hub IP from the local area network, and it also went through 128.64.10.1, which we all have on this router over here. This is 10.10.10.2, and we also have 128.64.10.1 on this router before it was able to get to our device that we are trying to ping on site A network. So this is how we set up a primary route. Now let's delete the path for the primary route and check if the host devices are still able to ping. Remember, we have a backup route, and the backup route comes on whenever the primary route is inactive. Let's try to ping .20.7 on the site B network and see if we are able to gain connectivity. Yes, we are able to gain connectivity because we've configured a floating static route on the routers, telling the router that whenever the primary route is down, the backup route should kick off, and this is done automatically. Let's also trace route the path that it's taking to get to that destination. And as you can see, guys, it is taking 128.64.20.2, which is on this network over here. So 128.64.20.2, then 10.10.20.1 before it got to the destination device. Now let's also check what route. So this is where we have 128.64.20.2 network, and we also have 10.10.20.1 on this router before it got to its destination device over here. Now if we try to connect back our primary route, remember Whenever the primary route is back on, the device automatically responds to the primary route, and the backup route goes back to inactive. So let's connect our primary route back and try to ping once again and see what's going to happen. Alright, so let's ping the default gateway of 20.1. Yes, we are able to ping default gateway of 20.1. Now let's ping 20.7 and we'll try to trace route one more time. Oops. Let's ping 20.7. So 20.7. Yes, we are able to ping 20.7. Now let's trace route to 20.7 and see what route it's taking to get to that destination. So it took the interface of 128.64.10.2, then it went to the next hop IP of 10.10.10.1 before it got to its destination. Previously, when we disconnected the primary route, it took this route to get to that destination, which is 128.64.20.2, and it was on this network. Now it is taking the actual path since the primary route is on. If we check one more time, it is taking the next hop IP of 128.64.10.2. Let's also check that. Now it's taking 128.64.10.2 to get to that destination. It is also taking the next hop IP of 10.10.10.1 before it got to its final destination. 10.10.1 is connected on this router over here. This router before it got to the destination host device. So in this video, we've explained floating static routes and how they are used as a backup routing mechanism in a network. You've learned that a floating static route is simply a static route with a higher administrative distance, which allows it to remain inactive until the primary route fails. Now, if this video helped you understand how floating static route is being configured on a router, why not hit the like button and subscribe, because on the next video we'll be talking about BGP, Border Gateway Protocol. Stay tuned and see you in the next video.